Elements, compounds, and mixtures. Elements and their position in periodic table. An element is a substance which consists of molecules made up of atoms of identical nature. It cannot be resolved into simpler entities by ordinary chemical processes. Till now, 118 elements are known to us, out of which 92 elements occur in nature and the rest are produced artificially. All elements known to us are placed systematically in a table called periodic table. It has groups where elements with similar properties are placed and periods. Elements are further classified into metals, non-metals, and metalloids. The bold line that you see in the periodic table separates metals from non-metals. Thus, 80% of elements known to us are metals and 19% are non-metals, while about 1% are metalloids. Dmitry Mendeleev. A Russian school teacher, Dmitry Mendeleev, 1834 to 1907, collected all the information about the known elements and wrote out a card for each one. Then, he arranged the cards in the order of their atomic weights to create the periodic table. Atomic number, elements, symbol, valency. 1. Hydrogen, H. 1. 2. Helium, He. 0. 3. Lithium, Li. 1. 4. Beryllium, Be. 2. 5. Boron, B. 3. 6. Carbon, C. 4. 7. Nitrogen, N. 5. 8. Oxygen, O. 6. 9. Fluorine, F. 7. 10. Neon, Ne. 0. 11. Sodium, Na. 1. 12. Magnesium, Mg. 2. 13. Aluminium, Al. 3. 14. Silicon, Si. 4. 15. Phosphorus, P. 5. 16. Sulfur, S. 6. 17. Chlorine, Cl. 7. 18. Argon, Ar. 0. 19. Potassium, K. 1. 20. Calcium, 2. Metals, non-metals, and metalloids. Elements that are hard, possess a shine, metallic luster, solid at room temperature, good conductors of heat and electricity, are called metals. Gold is a metal. Due to its luster, we make ornaments out of gold. Copper is another metal. You must have seen that the electrical wire which emerges out of the insulated layer of plastic is shining red in color. It is made of copper because copper is a good conductor of electricity. Metals have been known to man from a very long time. They play a very important role in our life. So much so that when you read ancient history, you come across division of different phases of history into Bronze Age, Copper Age, Iron Age, etc. Non-metals are just opposite of metals. They are generally gaseous or soft solids. Bromine is the only non-metal that exists as liquid at room temperature. Oxygen that we need for our survival is a non-metal and exists in gaseous state. Metalloids have the property of both metals and non-metals. They are very few but have their uses. Fact: there are 26 alphabets. There are 105 elements. Elements are like alphabets. You join alphabets to form words. Similarly, you join elements to form compounds. If you don't join alphabets properly, you just get a jumble, which is same as a mixture. Do you know? Alphabets or letters are classified as vowels and consonants. Elements are also classified as metals and non-metals. Compounds. When atoms combine in a definite proportion, we get a compound. As discussed earlier, water is a compound. Both elements and compounds are pure substances, but they differ in their composition. Elements are made up of only one type of atoms, while compounds are made up of different types of atoms combined in a fixed ratio. Characteristics of compounds. Compounds are formed by chemical combination of elements. Compounds contain elements in a fixed ratio. This ratio remains undisturbed and is independent of method of formation of the compound. Water contains hydrogen and oxygen in the ratio 2:1. Whether you prepare water by burning hydrogen in air or by heating a hydroxide, the ratio of hydrogen and oxygen will remain the same in water. Properties of compounds are totally different from that of combining elements. The salt that we eat is sodium chloride, which is made of sodium and chlorine atoms. Sodium is a metal which catches fire when placed in water. Chlorine is a gas with choking odor. Neither sodium nor chlorine are good for human consumption, but NaCl or sodium chloride is essential in our diet. Its over or under consumption cause diseases in us. Compounds have a molecular formula. Remember, we talked of alphabets which we compared to elements, and we compared compounds with words which are made of alphabets. Every word has a fixed spelling. Similarly, every compound has a fixed molecular formula. Organic and inorganic compounds. In olden days, compounds were obtained either from living organisms or from minerals. The compounds obtained from living organisms were called organic compounds, whereas those obtained from minerals were called inorganic compounds. It was thought that organic compounds could not be made in the laboratory. However, nowadays organic compounds are prepared in the laboratory in large numbers. They contain carbon and one or more of the elements. However, carbon monoxide, carbon dioxide, and carbonates are considered to be inorganic compounds, even though they contain carbon, as they are obtained from mineral resources. Mixtures. If two or more substances are mixed together in any proportion, such that they do not undergo any chemical change but retain their individual properties, then the resulting substance is called a mixture. For example, mixture of sand and water, mixture of sugar and water, etc. Although the examples mentioned here are examples of mixtures, yet they differ from each other. A mixture of sand and water, when allowed to stand for some time, separates into a sediment of sand at the bottom and water above it, while nothing of this sort occurs in the mixture of sugar and water. This means that mixtures are of two types. One with same composition throughout, while the other with varying composition. Chemically, the first variety is called homogeneous mixture, and the second one is called heterogeneous mixture. Types of mixtures. Homogeneous mixtures. In a homogeneous mixture, the components are mixed together completely. It has a uniform composition and properties throughout the mixture. Alloys and solutions are examples of homogeneous mixtures. A mixture of salt and water is an example of homogeneous mixture. Activity. Take two beakers and mark them as A and B. Put some sand in beaker A, half filled with water. Stir it well. Can you still see the sand particles in water, or do they disappear? Now, put some sugar in beaker B, half filled with water. Can you see the sugar particles in water? They disappear as they uniformly dissolve in water, resulting in a homogeneous mixture. Solution. A solution is an example of homogeneous mixture. A solution is formed when a solid is dissolved in a liquid. The substance which dissolves is called a solute. In the activity, sugar dissolves in water. So, sugar is a solute here. The substance in which the solute dissolves is called the solvent. In the above activity, sugar is dissolved in water. So, water is a solvent here. A solution containing water as solvent is known as aqueous solution. Alloy. A homogeneous mixture of two or more metals, or a metal and a non-metal, is called an alloy. For example, bronze is an alloy of copper and tin. Brass is an alloy of copper and zinc. Heterogeneous mixtures. In a heterogeneous mixture, the components are not mixed together completely. That is, the components are not uniformly distributed. The components can be seen separately. Its properties also vary throughout the mixture. Suspensions and emulsions are examples of homogeneous mixture. Suspension. A suspension is formed when an insoluble solid is added to a solvent. Such a heterogeneous mixture, in which solute particles are spread throughout the solvent without dissolving in it, is called a suspension. For example, chalk powder dissolved in water forms a suspension. Some medicines and syrups administered to children are in the form of a suspension. Emulsion. An emulsion is formed when one liquid is dispersed as tiny droplets throughout another liquid. For example, the milky-looking liquid formed by mixing cooking oil with water is known as an emulsion. When you shake the mixture of oil and water vigorously, the oil breaks up into tiny droplets, which are small enough to float in the water. This makes the water appear milky. Common properties of mixtures. In spite of dissimilarity in composition, there are certain properties which are common to all mixtures. They are: mixtures have a variable composition. It means that mixture of any two things can have components present in varying proportions, unlike compounds. For example, water prepared by any means will contain hydrogen and oxygen in the ratio 2:1. But a sugar solution can contain varying amount of sugar present in water. Preparation of mixtures is a physical change. The components of mixture retain their properties even after they are mixed with other components. Properties of mixtures are sum total of properties of its components. For example, air contains oxygen, carbon dioxide, nitrogen, etc. Hence, it supports life, property of oxygen, turns lime water milky, property of carbon dioxide, does not allow things to burn rapidly in atmosphere, property of nitrogen. No energy change takes place during formation of mixture. Components of a mixture can be separated by physical means. For example, if you want to separate components of a mixture of sugar and sand, just add water. Sugar dissolves in water. Now, decant the water. You will get back sand as a sediment, and on evaporating this solution, sugar would be obtained. Need for separating the components of a mixture. To obtain two different but useful components of a mixture. To remove harmful components or impurities from a mixture. To remove non-useful components of a mixture. Methods of separation of mixtures: hand picking, winnowing, threshing, sieving, sedimentation and decantation, filtration, evaporation, sublimation, distillation, centrifugation. All the methods mentioned above are based on the properties of components of mixtures. Do you know? Sometimes a solid turns straight into a gas. This is called sublimation. It is what happens with dry ice, used to make dramatic-looking clouds on stage in a theater. Dry ice in real is frozen carbon dioxide. Mixtures. Size of particles differs or difference in color of particles. Hand picking. One of the components is very light. Winnowing. Size of particles differs, but difference is not much. Sieving. One of the components is heavy and insoluble in water. Sedimentation and decantation. One of the components is insoluble in water, but is not heavy and remains suspended in water. Filtration. Soluble component but does not evaporate or vaporize on heating. Evaporation. When soluble components as well as water is to be recovered. Distillation. Insoluble component but solid is very finely distributed in solvent. Centrifugation. Separation of different components of a mixture. Mixture can be separated into its components. Separation totally depends on the nature of its constituents. Methods of separation of solid-solid mixtures by using solvent. This method is used for separating the components of a mixture in which one of the components is soluble in a solvent, while the other component is insoluble in it. Some examples are given in the table herein. Table showing examples of methods of separation of solid-solid mixtures. Solid-solid mixture. Solvent. Soluble component. Insoluble component. 1. Carbon plus sulfur. Carbon disulfide. Sulfur. Carbon. 2. Sand plus wax. Turpentine oil. Wax. Sand. 3. Common salt plus sand. Water. Common salt. Sand. 4. Sulfur plus charcoal. Carbon disulfide. Sulfur. Charcoal. 5. Niter. Potassium nitrate plus charcoal. Water. Niter. Potassium nitrate. Charcoal. Procedure. 1. An appropriate solvent is selected such that one of the components of the mixture is soluble in it. 2. Add to the mixture the selected solvent in such a good amount that the soluble component dissolves in it completely. 3. Filter the solution, leaving behind the insoluble component as a residue on the filter paper. 4. Collect the soluble component as filtrate. 5. The filtrate is evaporated by slow heating or leaving in the sun, and the soluble component is left behind. 6. The insoluble component is dried or reused. 7. This is the method of separation of solid-solid mixtures. Methods of separation of solid-liquid mixtures. Filtration. This is the simplest method for the separation of a mixture and is used when a mixture contains one solid component insoluble in the other liquid component. The mixture is filtered. The solid left behind on the filter paper is called residue, and the clear liquid that passes through the filter paper is called filtrate. A few examples are given in the table below. Table showing examples of solid-liquid mixtures separated by filtration method. Solid-liquid mixture. Residue. Filtrate. 1. Silver chloride plus water. Silver chloride. Water. 2. Chalk plus water. Chalk. Water. 3. Barium sulfate plus water. Barium sulfate. Water. Procedure. 1. Take a filter paper in a circular shape. Fold it into a semicircle and then into a quarter circle. 2. Open the filter paper into a cone with 3 layers on one side and 1 on the other side. 3. Spread this filter paper in a conical funnel. 4. Clamp the funnel to the stand and place an empty beaker below the funnel, such that the stem of the funnel is along the well of the beaker. 5. Slowly pour the mixture along a glass rod as shown in figure. 6. The solid residue remains on the filter paper and the liquid passes through. Advantages of filtration. 1. The components of the mixture are completely separated. 2. It takes little time for the separation of the components. Evaporation. A process of change of a liquid into gaseous state below its boiling point by absorption of heat is called evaporation. This method is used for separating a non-volatile solid from a liquid. A few examples are given in the table below. Table showing examples of solid-liquid mixtures separated by evaporation method. Solid-liquid mixture. Non-volatile solid. Liquid. 1. Sodium chloride plus water. Sodium chloride. Water. 2. Sulfur plus carbon disulfide. Sulfur. Carbon disulfide. 3. Magnesium sulfate plus water. Magnesium sulfate. Water. Procedure. 1. Gently heat the mixture of a non-volatile solid and a liquid in a china dish over a sand bath. The liquid will evaporate but will not boil. 2. Continue heating till the liquid completely evaporates. 3. Stop heating when the solid becomes dry. Limitation. There is loss of liquid component in this method of separation. Water evaporates and residue of salt is left behind. Distillation. The conversion of a liquid into its vapors and condensing the vapors back into the liquid is known as distillation. It, thus, consists of two processes, vaporization and condensation. That is, distillation is equal to vaporization plus condensation. This method is used for the separation of a liquid containing a non-volatile solid component dissolved in it. A few examples are given in the table below. Table showing examples of solid-liquid mixtures separated by distillation method. Solid-liquid mixture. Non-volatile solid. Liquid. 1. Sodium chloride plus water. Dissolved solid. Sodium chloride. Water. 2. Iodine plus methyl alcohol. Iodine. Methyl alcohol. 3. Iodine plus chloroform. Iodine. Chloroform. Procedure. 1. The mixture is taken in a distillation flask which is connected to a Liebig's condenser, water condenser. 2. The flask is kept in a water bath if the boiling point of the liquid is below 100 degrees Celsius. Otherwise, a sand bath is advised. A few glass beads or porcelain pieces may be put in the flask to prevent bumping of the liquid during heat. 3. A thermometer is fitted in the neck of the distillation flask in such a way that its bulb is near the side tube of the flask. 4. The flask and the condenser are clamped, and the bare end of the condenser is connected to a receiver to collect the distillate. 5. On heating, the liquid vaporizes at its boiling point, and the vapors are condensed as they pass through the condenser. 6. The pure liquid is collected in the receiver while the non-volatile solids is left behind in the distillation flask. Methods of separation of liquid-liquid mixture. The liquid-liquid mixture can be separated by the methods tabulated in the table below. Table showing methods of separation of liquid-liquid mixtures. Method. Physical property used for separation. Example. 1. Using separating funnel. A. Immiscibility of the two liquids, that is, the two liquids do not dissolve in one another. B. Difference in the densities of the two liquids. A. Carbon disulfide plus water. B. Chloroform plus water. C. Kerosene oil plus water. 2. Fractional distillation. A. The two liquids dissolve in one another, that is, are miscible. B. Difference in their boiling points. A. Ethyl alcohol, boiling point 78 degrees Celsius, plus water, boiling point 100 degrees Celsius. B. Methyl alcohol, boiling point 64.5 degrees Celsius, plus acetone, boiling point 56.5 degrees Celsius. Using separating funnel. This method is used for separating two immiscible liquids in a mixture. A few examples are given in the table below. Table showing examples of liquid-liquid mixtures separated by using a separating funnel. Immiscible liquid-liquid mixture. Heavier liquid, lower layer. Lighter liquid, upper layer. 1. Chloroform plus water. Chloroform, water. 2. Carbon disulfide plus water. Carbon disulfide, water. 3. Carbon tetrachloride plus water. Carbon tetrachloride, water. 4. Kerosene oil plus water. Water. Kerosene oil. 5. Turpentine oil plus water. Water. Turpentine oil. 6. Benzene plus water. Water. Benzene. Procedure. 1. The liquid mixture consisting of the two immiscible liquids is put in a separating funnel. 2. The two liquids separate into two layers. The heavier liquid forms the lower layer and the lighter one forms the upper layer. 3. On opening the stopcock, the heavier liquid flows down and can be collected in a beaker. 4. Close the stopcock as soon as the last trace of the heavier liquid has flown out. 5. On opening the stopcock again, the lighter liquid flows out and is collected in another beaker. Sublimation. Some substances change directly from solid to gas on heating. Such a conversion is called sublimation. When cooled, the vapors of such substances directly solidify. The solid thus obtained is called a sublimate. Iodine, ammonium chloride, and naphthalene are common substances that sublime. A direct change of state from a gas to a solid is called Deposition. Fractional distillation. It is used to separate the two miscible liquids having boiling points differing by 10 degrees Celsius to 20 degrees Celsius. When the distillate is collected in fractions at different temperatures, the process is known as fractional distillation. It is employed when the sample contains two or more close boiling liquids. In such a case, the fractions collected in the normal distillation are always contaminated, and these have to be purified by repeated distillations. In order to reduce the number of distillations, a device called fractionating column is fitted between the distillation flask and the condenser, and the process is known as fractional distillation. A fractionating column gives the effect of repeated distillations by offering resistance to the upward movement of the vapors. Fractional distillation is based on the physical property of different boiling points of different liquids. The liquids with lesser boiling points vaporize at lower temperature and are distilled first, followed by liquids with higher boiling points. Finally, the last to be distilled is the liquid with the highest boiling point. Table showing examples of liquid-liquid mixtures separated by fractional distillation. Miscible liquid-liquid mixture. Component distilling over first. Ethyl alcohol. Boiling point 78 degrees Celsius. Plus water. Boiling point 100 degrees Celsius. Ethyl alcohol. Benzene. Boiling point 80 degrees Celsius. Plus toluene. Boiling point 111 degrees Celsius. Benzene. Acetone. Boiling point 56.5 degrees Celsius. Plus water. Boiling point 100 degrees Celsius. Acetone. Acetone. Boiling point 56.5 degrees Celsius. Plus ethyl alcohol. Boiling point 78 degrees Celsius. Acetone. Procedure 1. The liquid mixture is placed in a distillation flask fitted with a fractionating column, a thermometer, and a Liebig's condenser, water condenser. 2. When the mixture is heated, the liquid vapors rise into the fractionating column, where they come in contact with the large cold surface of the column and get cooled. As a result, the vapors of high boiling liquid condense out first and flows down into the conical flask. 3. The process is repeated at every obstruction of the fractionating column, and, as a result, the ascending vapors become richer and richer in the low boiling liquid. By the time the vapors reach the top of the column to enter into the condenser, they contain the vapors of only one component, which, of course, is a more volatile, low boiling component. 4. The liquid is finally collected in the receiver, and the portion of the mixture left in the flask may again be recycled separately to ensure complete separation. Limitation. Liquids forming constant boiling mixture cannot be separated by this method. Chromatography. The term chromatography is a Greek derivation which means color writing. In Greek, chrome is equal to color and graphy is equal to writing. It is a modern and the most efficient technique for the separation of colored substances in liquids into their individual components. It is defined as a process of separating different dissolved components of a mixture by differential adsorption of the components over an appropriate adsorbent material. It is useful for 1. Isolation of compounds from natural sources. 2. Separation, purification, and identification of the constituents of a mixture, both colored and colorless. Paper chromatography. In this method, we use chromatography paper. A fine spot of the sample is placed on the chromatography paper. This paper is suspended over the solvent kept in a glass cylinder. The solvent moves up, diffusing through the paper strip, carrying with it the substances of the mixture present in the spot placed on the strip. The substances which are adsorbed strongly on the filter paper, stationary phase, move slowly, while the substances which are dissolved strongly in the solvent move with high speed. As the solvent moves up, different spots appear on the filter paper strip. After some time, the chromatography paper is removed from the cylinder and dried. The final positions of the different spots and the solvent on the paper are marked. This marked filter paper is called chromatogram. Advantage of paper chromatography. 1. Only a small quantity of the sample is needed. 2. The substances are not consumed during the separation.